detail in internal one first.
Okay.
And low pressure created at inlet wall, so suction can be done here. So as suction done, these liquids are passed over the teeth, in between teeth of gears, and as
Okay.
peripheral of the gear, and
Okay.
passed over the circumference of outer walls, I mean internal walls of the uh,
Casing, pump casing.
casing, yes sir, casing, and just pumped outside from the outlet.
Yeah, that's good. So this is the very basic, simple principle, working principle of your oil pump. Uh, if you will see, I will show you one actual working of that gear pump also. So there is a gapping between the teeth of these gears. Okay. In actual condition, this is a schematic representation. Then that picture will be more clear. Okay. So this is that same diagram. This is that gear pump. Now what, this is also a gear pump with pressure relief valve. What is the role of a pressure relief valve? Whenever on the outlet side you have excess pressure than the required value, okay, then what it will do, it will release the extra pressure by sending the oil from this side, and it will bypass it to your inlet side once again. Now how it will bypass, this is the question. Any other student? Right now it was Rahul Gandhi, na? Some other student. How this bypass and this spring pressure relieving valve is working? This ball valve. Can anyone tell me? Simple basic physics.
That spring is loaded up to certain pressure, sir.
Okay.
If the pressure exceeds at the outlet side, the ball will be lifted using the pressure and it will go into the inlet.
Very good. So every spring you have studied in your design of machine member. Okay. So you have gone through that spring constant or spring stiffness also. So after certain force, the spring will start deflecting. Okay. So when the pressure on the outlet side will increase certain threshold value, then what happens? This ball will lift up. This ball will lift up, and if the ball will get lifted up, the excess pressure or the liquid creating that excess pressure will get bypassed from this parallel channel, and it will come again back to your inlet side. So this is also a gear pump. Now another type of pump we have, that is our rotor pump. Yes, now you are in your final year of engineering, all of you. By looking at this figure, who will explain me the working of this pump? Some other student. I want everyone to participate in this discussion.
Sir, it's like Geneva mechanism where the fluid is moved by the outer layers.
Okay.
Uh, as it has when when the upper layer, outer inner part moves, that moves the pressure outside it to the next zones.
You can see the gapping. Okay, in inlet side, okay, the gappings are less. Suppose it will be parallel, face to face. In between you will be having your lobes. Okay, and this is your inlet port, this is your exit port. In between these two there are some gap where your lobes are there. Okay, so what is happening, when this gapping is more, from there the suction of oil is being done. Okay, now you can see the area is increasing, so more amount of oil will be sucked in. And what happens if I am going to compress it? Compress it means I'm going to lessen the area. On this side you can see the area is being reduced on this side, so it will automatically deliver oil with higher pressure. This is the simple. You are just controlling the gap between two contacting parts. Wherever you have, suppose you have oil in this much amount of area, and now you are providing this much only space for the oils to escape out, then definitely it will go with higher pressure. So that principle, all these pumps are utilizing, whether it is your gear pump, and definitely specifically I'm talking about this rotor pump also. Okay, so one last pump is, no, we have two more pumps. This is our plunger type pump. Plunger you have studied in your fluid mechanics. So it is a reciprocating type of pump. Now, anyone who wants to explain this diagram, simple diagram. One ball valve is there and that is controlling all the things.
When the pressure is low in the cylinder, sir,
Yes.
inlet valve is going to push the inside and
Okay.
oil is sucked into the cylinder
So how that low pressure is creating?
by moving the plunger.
Yes, this plunger you can see here, all of you. This plunger is moving in upside direction. So a low pressure will be created in this portion. When a low pressure will be created in this side, what will happen? This ball will try to come on to this side. Okay. Why? Because here you have low pressure. And on this side also, this ball will try to move on this side as you have low pressure over here. So when this ball is not allowed to move inside beyond this limit, so this valve will be closed, this passage will be closed, no oil is allowed to move in from the outlet side. And when this ball will come on to your left hand side, then what will happen? This inlet valve passage will get open. Okay, so oil will enter from this side into this chamber, and again when it is coming down, reverse or vice versa will act over here, and this will be closed and this will be forced to open, so that pressurized oil will go to from your outlet port to different lubricating parts. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay, so these are simple physics behind all these working pumps. Now we have one more type of pump, that is our vane pump. Okay, who is going to explain the working of this vane pump? I have taught you, I think, two subjects, fluid mechanics and finite element method. So in those two subjects, I was more active. Now in this automobile subject, I want students' participation. So this will be a rather discussion classes, so that more output will come from your side. Yes, who is going to explain me about the working of this vane pump? I will help you, don't worry. Anyone from the girls? Is there any girls in the class? Lateral entry? Yes, I'm waiting for the response. Anyone from the girls? Okay, no issue. See what is happening here. You have two eccentric circles. The first circle you can see this one, the outer one. And the second one is your this inner one. These are eccentric. Eccentric means they are their centers are not coinciding. So you can see here, this is your first center and this is your second center. This one is for your the outer periphery. So what happens with this eccentricity? Again, we are controlling this space, inlet and exit space. Okay, and how we are creating the pressure over here, you can see here there are some slots cutted in your inner periphery. Slot is cut in over there, slot cutting is there, and some small piston kind of thing is over here that is pushed to be in contact with the outer wall, okay, with the help of some spring. Here it is not shown in this figure, but some spring is there at every lobe, veins, I can say here, this red color, or I will change the color to represent it as a spring. So these springs, what they are doing, they are pushing these small pistons, okay, or sliding vanes, rather it is written here. Sliding vanes are there. They are capable of sliding from the top level to the bottom level. Okay. Suppose this is your extreme position. So from here, they can slide from here up to inside portion. Okay, so those veins have the capability to slide inside that cut grooves, and they are pressed to touch the outer periphery with the help of your springs. So this is how they are creating or pushing. Suppose some fluid is over here, inlet is from this side, oil is coming into over here. Then since your this inside rotor is rotating in this direction, okay, so what will happen, the oil sucked, it will move in this direction. Okay, so what will happen, you have studied in your fluid mechanics, when the cross sectional area is changing, then what will happen, using your continuity equation, a1 b1 equals to a2 b2. Okay, do you remember that equation? Continuity equation.
Yes, sir.
Yes. So here you can see that the cross-sectional area is changing. If cross-sectional area is changing, then definitely there will be some change in the velocity. Okay. And if there is some change in velocity, then you can apply your Bernoulli's also. And finally, in simple language, you try to understand that is pushing from this smaller area to get the oil at very high pressure. So this is the working of your vane pump.
Sir, you shown
Yes.
the direction. Sir, you have shown one direction also. If the veins rotate in the direction, the pressure will be not increased now.
If suppose this is your rotor, inside rotor, it is rotating in this direction, means it is your clockwise direction. Okay, so
Yes,
this
sir.
rotor is rotating. Okay, and if the rotor is rotating, these sliding vanes, they must have some weight. Got my point?
Yes, sir.
So when something is fixed or something is attached to the rotating, some sound is coming. Can you please mute yourself? Yeah. These vanes are attached to the rotating component, suppose any rotating component, and it is having some mass. So due to the centrifugal force, automatically what will happen? That mass will try to move outside. Okay. This mass will automatically try to move outside due to its centrifugal force. And that force, along with this spring also, they are controlling to make a contact over here. So its purpose is only to maintain the contact at every location. Suppose at instant t1, it is at this location. I am writing here t1. At instant t2, okay, suppose that position is at this location. I will change the color. At instant t2, your vane is coming at this location. Okay, so then what will happen? That spring, the centrifugal force, that centrifugal force will try to push that vane to the outer obstruction, or to the outer, what we can say, outer limit, and that limit is provided by your this case, as well as your spring is also acting there. Okay, so it will push the fluid coming inside, and it will move, and it will push the oils to go in this direction. And this is the only what is required. You have to push the oil. Now from larger area, it is moving toward this smaller cross sectional area, and from this side you are having your outlet. So this is how the working of vane pump is explained. Sai Sunai, now it is clear.
It is clear, sir.
Okay. Since they are schematic diagrams, so here you can see the inlet port is showing from here up to here. Okay, and outlet is also showing from here up to here. But in actual conditions, it is little bit different. For understanding, it is drawn like that. But when you will see in your actual engine, it is little bit different. When it is coming to this smallest portion of area, then your outlet port will be connected at that location, so that you can get maximum pressure. I have one video to show you about the actual how it is working, but I have not included in this slide. I will show it to you, don't worry. Can you see engine on your screen?
Yes, sir.
Yes, sir.
Okay, now let's see how this oil pump is working. Okay, inside an engine, one mechanic will come and he will just break it, disassemble all the parts and show you and explain you how it is working. So all of you, please pay attention. This part is your filter and this is your pump, this location. So once you will see the video, picture will be more clear.
Hello everyone, it's the Motorcycle News here. And I just wanted to do a quick video to explain how the oil pump works on a motorcycle.
Audio is going to that side?
Yes, sir.
Yes, sir.
Engine. So I've removed the clutch cover from this particular engine, and I've actually already removed the oil pump, which is just this unit here. So it's secured into the engine with just 2 small bolts. And when it's fitted in the engine, it just slots in here. Okay, so I've removed the two securing bolts, and I'm able to remove the actual oil pump. So the oil pump itself consists of essentially 3 components. First of all, we have the driven gear, and this is the gear that drives the oil pump. And the second component in the oil pump is the inner rotor, and the third component is the outer rotor. So the inner rotor and the outer rotor, they're contained in this little metal unit here. So I'll open that up in a few minutes, and you'll get to see what the inner rotor and the outer rotor look like. But just to mention that this particular oil pump with the inner rotor and the outer rotor is called a trochoid oil pump. So a trochoid oil pump is a very common oil pump to find on most motorcycles. And the reason being that it's very simple and it's also very reliable. So let's start by removing the driven gear. Okay, so the driven gear, when it's fitted into the actual engine of the motorcycle, driven gear is actually driven by the engine itself. So if I just hold it in like that, and if I just turn this, so this is the end of the crankshaft. So the oil pump is actually, the oil pump driven gear is driven by gears hidden behind this oil filter. So as the engine is running, the crankshaft is turning, and it turns the driven gear. And the driven gear rotating acts on the inner rotor inside here, and it's the inner rotor combined with the outer rotor that actually pump the oil. So you can see here the surface, the mating surface where the oil pump fits onto the actual engine, that we have 2 little black oil seals. Now the first one here at the bottom on the left hand side, that is where the oil feeds into the oil pump. So this is the input, and this is the output. So this is where the oil feeds from the oil pump back into the engine to be pumped up through the engine. And you can see on the oil pump itself that we have these 2 holes in the oil pump, and they correspond to the input and the output. So the input is actually this one here. So the input is this one here, and the output is this one here. Okay, so when it's in, as this is rotating, the cavity in the oil pump sucks in the oil through the input port, and then it pumps out the oil through the output port. So the driven gear is actually held on with just a simple circlip, so I can quite quickly remove that. So I just need a little flathead screwdriver, and I can actually, you can just see me, I can just push it off. So it's just a little circlip. Leave that there. And with the circlip off, I can remove the actual driven gear. So it's a tight fit. I can use my screwdriver again just to give it a little bangs. Won't take much to knock it out. There we have our driven gear. So as you can see, this particular gear is made of plastic. It's probably quite a hard plastic. The reason being, it's possibly the only gear in this engine that is made of plastic. Well, the reason is that it is it's not going to be under huge pressure. All it's pumping is oil, so it's probably at a couple of bar pressure. So the forces on this gear are not huge. So
this person is saying that the driving gear that you have seen just now in this video is made up of plastic. So the question might be coming, why it is made up of plastic? So the explanation he gave that here there is not much high pressure, so it is a hard kind of plastic. So its only function is to just provide the driving force to your gear pump. So that's why they have used this as a plastic gear.
In a lot of motorcycle engines, this driven gear will be made from metal. In this case, it's made from plastic, probably to save weight. Now, with the driven gear off, I'll just put it to one side along with the circlip. You can see here that there is two holes, and these are the two, sorry, this side here, there's two holes, and these are the two holes where the two bolts fit in to secure the oil pump to the engine of the motorcycle. Okay. And if we turn it around, this is the side. This is what the driven gear fits onto. You'll notice that it is not fully circular, and the reason it's not fully circular is that it allows for the
So here you can see that to fix this gear on the shaft, it is not completely circular. So some flat portion is there to provide a locking function of the gear on that shaft.
Slot on, and now on the other side, we can see again, this is where the bolts come through that secure it to the actual engine. One there, one here. Again, we have our input port here and our output port there. So I'll just turn it this way. And I can open this oil pump up by just removing these two screws. So with a Phillips head screwdriver, and then I have access to the unit, to the oil pump itself inside of it. So the way the oil pump, just to explain it essentially, how the oil pump works, the oil is sucked in here. So as I'm just going to rotate this, I'm just going to turn this little rotor to drive the oil pump, and you're going to be able to see, hopefully. So you're going to be able to see that there is essentially the rotor is actually a little gear. It's a funny shaped gear. So it has a number of teeth, and the teeth are all rounded off. And what you'll notice is on the input port that the teeth from the inner rotor don't gel up or match up exactly with the teeth on the outer rotor. There's actually a little bit of a space or a cavity, and that cavity is what is created as the rotors turn around, and that's what sucks in the oil. And what you'll also notice on the output port, where the oil is pumped out from the oil pump, that the teeth on the inner rotor gel almost perfectly with the teeth on the outer rotor. And by doing so, they actually force the oil out. So as it's rotating, there's a cavity here between the teeth which sucks in the oil, and then as it rotates, that cavity closes. So by the time it gets to the output port, that cavity has closed and there's less space for the oil to sit, and it's forced out through the output port. So that's essentially how the oil pump works. It's very simple, very effective, and very reliable. So I'm just going to remove these two Phillips head screws. They're going to be torqued on quite tight. I've already broken them loose so that they're easy to come off. Okay. So as you can see, it's just a simple short screw. That's one. Just do the second securing bolt, and I can lift the lid off this oil pump. Side as well. Okay, so now with the two securing bolts off, I can just remove the lid. Okay, so it's just a simple metal lid. Its role is essentially to secure the inner rotor and stop it from falling out. So with the lid off the oil pump, I can rotate the drive shaft, which acts on the inner rotor. So you can see here the inner rotor, this is the drive shaft. I'm just moving it up and down. It acts on the inner rotor, or the inner gear. And as you can see, the spacing on the left hand, spacing between the teeth of the inner rotor and the outer rotor is, on the left hand side there is really no space, but on the right hand side there is plenty of space. And the input port again is on this side, and as you see, as if you watch one of the teeth moving around, okay, so let's take this one here at the very bottom. Just watch it moving around. It's opening up a space between the inner and the outer rotor gear teeth. So that as it moves, that space is getting greater, and that actually sucks in, that cavity sucks in oil. And as it keeps rotating, you'll notice that the oil is trapped between the teeth, and it actually closes up. So it's almost closed here. So there, at this point, it is closed up fully, and this is where the output port is. So the oil has nowhere to go but to be forced out through the output port, and it's pumped.
Yes. So here you have seen how its function is very good, in a very good way he have elaborated. At this location, if you are able to see my cursor on the screen, at this location, very small gap is there where your inlet port is there. And as this inlet gear is connected to your drive shaft, and once it is started moving on your anti-clockwise direction, a cavity is created. That cavity is allowing to suck the oil from the inlet port, and that is moving in this direction between the gap of these two gear teeths. And finally, when it is reaches at this location where you have very less space or no space, beyond this point you can see you have no space between the teeth of two gears. So at this location the oil is forced out to go to your delivery port. Now let's listen ahead.
Through the cavities in the engine block to lubricate the various components of the motorcycle engine. So that oil will be pumped up the whole way through the different cavities that are in the block of the engine. They'll be pumped up actually through some cavities here on the cylinder. It'll be coming up here and it'll be lubricating the the various components. There will be also lubrication of other components around the motorcycle engine on a lot of engines. It really does depend on the motorcycle engine. There's a lot of different moving parts and they all have to be kept well oiled to make sure that the engine doesn't seize. Okay, so that's the description of how the oil pump works. So let me just remove this shaft. So the shaft actually with the lid off, I can actually push it out very simply. So I'll just push it out. Okay. So it's actually this little pin is what secures the shaft to the inner rotor and causes it to turn. So when I remove this inner shaft, I can then remove knock out the inner rotor and give it a tap. It's not coming out that easy. So let me just give it a little bit of a push maybe. There we go. But there you can see, that's our inner rotor. It's just a little metal gear. That's it. It's quite simple, just a little metal gear with rounded edges. And you can see again, the outer rotor is just a mismatched surface essentially. So it fits in, the inner rotor fits into the outer rotor, but not exactly. And that's the key to how an oil pump works. Last thing to show you here is that there is two little oil seals, little black seals that you can see on the input and the output ports. And their role is just to make sure that there is a secure or a tight bond between.
So these are the oil seals that are preventing the oil to be leaking or lose unnecessary losing of the pressure. So that's, you have seen in this video, the complete disassembly of your geared oil pump of this motorcycle engine. So now I am sure that all of you must have understand this working of this gear pump. Is it so?
Yes, sir.
Okay, so that's all for today's class. In the next class, we will see about oil filters.